In today's video, we're going to be looking at the first half of chapter 3. So we're going to be covering 3.1 through 3.3, and it covers a couple of different areas. Chapter 3, basically as a whole, looks at different ways that we can show data, okay? Whether that be in a type of table or whether that be in a type of graph, okay? So today we're going to look at two different ways of doing this. We're going to look at half of the graphs that you can use to represent data, and you can also look at frequency distributions, which we'll see are tables, okay? So they're all different ways that we can represent the data that we find when we do some kind of study, okay? Normally, in this case, an observational study. Remember from last time, an observational study is just something where you have observed something. So you see, let's say, how many times a sports team won in a particular season. Okay, we're not dealing with placebos or anything here. Okay, we're just dealing with how many times we observe something. Okay, first thing we're going to look at though is some terminology that you're going to need before we go into these graphs and frequency distribution tables. So we're going to look at two types of data. Qualitative data is anything that uses words, okay? So where you've done a survey on some people to see, I don't know, let's say what someone's favourite colour is, okay? That's an observational study, okay? You're just hearing what someone says and you're recording it, okay? There's no kind of experiment happening here. When someone answers what colour is their favourite, okay, it's a word. Okay, red, blue, green, etc. Okay, so the answers, the data that you get back is in word format. Okay, that is qualitative data. Quantitative data, as you would imagine, is anything that's numerical. So any kind of numerical data that you have. Okay, someone's height, someone's weight, etc. Okay, so qualitative data uses words, quantitative data uses numbers. Now, you can split these into two categories, okay, on each one. Two types of qualitative data are nominal data and ordinal data, okay? They're both very, very similar, okay? But there is one slight difference between the two. Nominal data is any kind of qualitative data where there is no scale to it, okay? So, for example, if I ask someone what their favourite colour is, okay? One colour is no better than any other colour. It's data that's in word format that has no scale. So it's qualitative data that has no scale. So, for example, colours. Okay, so you ask someone what their favourite colour is, they tell you it's in word format, but there is no scale to it. Okay, it's just a bunch of random colours. Ordinal data is very similar, but this time what you're doing is it's got some kind of a scale to it. Okay, it can be put into categorical format, as they put it. Okay. So, for example, you can say for someone, okay, I was very satisfied with one experience, okay? They've given you an answer, okay? If you ask someone how satisfied they were with a particular experience, they could say, I'm very satisfied. They could say, it was mediocre, or I was not satisfied whatsoever, okay? This data has some kind of a scale to it, even though it uses words, okay? A different type of thing for ordinal data would be, let's say, you ask someone what level of education they have, okay? You could say that someone has a high school diploma, they have a bachelor's degree, they have a master's, they have a PhD, okay? There is a scale to it as you go up, okay? The more degrees that you have as you go up. So it's still in word format, but there's a scale to it. Now, there's two different types of quantitative data. Hopefully I can fit this in here. There's interval data and ratio data. Okay. Interval data means that you have numerical data, but there is no true zero. What do I mean by that? Normally, the best way of, like the best example of this so that you can see this in action is temperature. Okay, well, you're going to say, well, you can have 0 on a temperature scale, you can have 0 Fahrenheit, you can have 0 Celsius. But 0 doesn't mean that there is an absence of temperature. Okay, there is still some temperature there. It's very cold, but there is still some temperature there. Okay, so what they class as 0 is not a true 0. It doesn't mean the absence of something. Okay, so temperature is a good example of this. The other way that they also describe this with temperature is to say that you can't have multiplication and division within that particular data. Okay, for example, looking at temperature. If you look at 10 degrees and 20 degrees, okay, 20 degrees is not twice as warm as 10 degrees, okay, because there is no true 0 in temperature, okay. It's just like a sliding scale that you have, but it doesn't mean it's twice as warm, okay. You can say that, but it's not technically true, okay. So because there is no true 0, you cannot do multiplication and division within that particular data. Okay, it's kind of a weird concept. On the other hand, ratio data does have a true 0. So it's numerical data that has a true 0. Okay, what does that mean? That means that, for example, height and weight are great examples of this, and time. Okay. If you say something is 0 inches tall, it means it's not there. Okay. If something has 0 weight, it's not there. Okay. If you have 0 seconds, it never happened. Okay. So it has a true 0. 0 means something. Okay. And also you can say, okay, I have something that is 2 feet tall and I have something that is 4 feet tall. Well, the thing that's 4 feet tall is exactly double the height of the thing that is 2 feet tall. Because you have that true 0, and 0 means the absence of something, okay, that means that you can multiply and divide within that numerical data. Something can be twice the height of something, something can be twice the weight of something, something is double the time of something. Okay, it actually makes sense. So they're the two different types of data. You can have qualitative data and quantitative data. And within that you have two different types, nominal and ordinal for qualitative, and interval and ratio for quantitative. Okay, so that's just a few pieces of terminology that you're going to need going forward. Okay, now I want to look at a couple of different types of graph that you're going to need. This comes up in 3.2 when you do that homework. Graphs are used to display data in a nice way, okay? It helps us to see what is happening. Okay, when you've just got a bunch of data like we have here that's in a table, it's very difficult to see really what's going on, especially when you have a lot of data. So if this table had, let's say, 100 rows, when you've just got a bunch of numbers, it's very difficult to see, in this example, who did the best at sales. Okay, it's very difficult to look through all the data. Whereas if you've got a graph, in this case a bar graph, you can see, well, whoever has the highest bar in the bar graph evidently had the best sales. Okay, so graphs are very, very important to display data. It's a great way of displaying it, and it's very easy to see what is happening within your data. Okay, when you do a bar graph, and this is going to come up in your application too when we look at doing some of these graphs on Excel, There's a few things that you must make sure when you do a bar graph, okay? This also comes up with other graphs, but bar graphs in particular. Make sure that your axes are clearly labelled, okay? It's a huge thing to make sure that you have both the right thing labelled, okay? So, for example, down the bottom here, it was actually cut off, so I had to write it in. If I didn't have the word salesperson at the bottom here, okay, I would just have a bunch of random names on the bottom. No one knows what that means, okay? So you have to make sure that you label both of your axes, okay? So we've got total sales here and the unit, which in this case is thousands of dollars. And on this axis here, you have the salesperson. So it tells me exactly what is on each of my axes. So whenever you do a bar graph and whenever you see a bar graph, make sure it is clearly labelled. Okay. Another thing that comes up more in statistics than it does in most math is making sure that the bar graph starts at 0. Statisticians really don't like it if you start a bar graph at any other number. Okay, in this case, we actually have our lowest number is 187. So what I could do is actually start my bar graph here at around 180, and I could have made that my x-axis. Okay. When you do that, you can actually see a bigger difference between each one of your bars within your graph. Okay, so if instead I would have started my bar graph at 180 and gone up in tens, I would have seen a bigger difference between each one of my bars in my bar graph. So it actually shows more of a difference and shows me that difference between each one of my bars. Whereas in this case, where I've started at 0, they all look to be pretty level. Okay, there's only a very, very slight difference in each one because my scale goes up in 50s. Okay. Statisticians just don't like starting bar graphs at any other number other than 0. So make sure whenever you see a bar graph in statistics, it starts at 0. Otherwise, they don't like it. Okay? It doesn't mean a lot to them if you start at another number. They don't see much point in it. So that's another thing to look out for. And one last thing to make sure when you've got a bar graph, make sure it has a title. Okay? To tell me what exactly is going on in that bar graph. Another type of graph that we have is a stacked bar graph. These are really good to show us more than one thing at once. Okay, so in this case, we're looking at the number of medals won by each country. Okay, what we could have done here is done 3 different graphs, and we could have said, okay, let's do a bar graph to show me how many gold medals were won by any particular country. Let's do a second bar graph that shows me how many silver medals were won by each country, and the last one that tells me how many bronze medals were won by each country. That's a lot of graphs to draw, okay? Instead, what they do is they say, okay, let's do a stacked bar graph, okay? Again, make sure it's got a title and make sure that your axes are clearly labelled and that it's got a decent scale that starts at 0. Another reason why we like this is because it shows us the totals, okay? I can see for any country the total number of medals won between both gold, silver and bronze. So it's very useful to kind of summarize data for us when you've got multiple things happening. Stacked bar graphs are good to summarize the data because I can see not only how many of each medal were won by each country, I can see the total number of medals won by each country. Whenever you read one of these, make sure you've kind of got to do a bit of subtraction here, okay? So for example, for let's say Russia, okay, it looks like about 13 gold medals were won by Russia. Then, if I come to here, I'm at 24 at this point, okay? So, the number of silver medals that were won, if this is 24 and this was 13, I know I've got 13 gold medals that were won, but the number of silver medals that were won would be 24 minus 13, which is 11. So, I know I've got 11 silver medals. And then to get the number of bronze medals, I'd come up to here, and that's probably, I'd say, about 33. So the number of bronze medals won would be 33 minus 24, because we're looking at this part here, which would be 9. Okay, so I've got, for Russia, there were 9 bronze medals, 11 silver medals, and 13 gold medals. Okay, so that's how you read those graphs. But as I said, make sure they are clearly labelled when you use these. Another type of graph I want to look at is a pie chart. Pie charts are used to show proportions of a whole. Okay, so whenever you've got a whole population of something, they basically tell you what proportion of the population satisfied a particular category. Okay, so for example, I'll do a very quick pie chart here. Okay, the whole thing represents 100%. So let's say I was looking at a particular bookstore sold 1,000 books one day. Okay, and one segment of my pie chart, okay, let's say that was about 1/5. Okay, 20% of the books that they sold were history books. Okay, and the whole population, which is 100%, I said was 1,000 books. Okay, what they may ask you is how many history books were sold that day. Okay, well, it's 20% of the 100%. It's 20% of 1,000 books, which would be 200 history books were sold that day. So make sure whenever you use pie charts, you can draw the actual numerical data back from it. Okay, it will give you the proportions for each particular category. Okay, so you could have 20% of them were history books. Let's say, I don't know, 10% were fantasy books. And then, I don't know, 30% could be like biographies. Okay, and you can keep going. Okay, but you must make sure that you can take a percentage of a whole number. Okay, because they will ask you that in your homework. They'll say, okay, how many biographies were sold on this particular day? Will you take 30% of 1,000, which is 300? So make sure that you can do that. All you have to do is turn your percentage into a decimal by dividing it by 100, and then multiply your decimal by the whole number. And that will tell you how many of that particular thing fall into that category. So that's all the graphs that you'll need to know for now. That will cover you for 3.2. I want to look at 3.3, which looks at frequency distributions. This sounds complicated, and it really isn't. A frequency distribution just tells you how frequent a particular thing happens. Okay? Or in other words, how many people or things fall into a particular range or category. Okay, so if we look here, I've got a frequency distribution. A frequency distribution is just a table. Okay, I have a frequency distribution of heart rates. So I have started out with 50 students, and I have their heart rates. Okay, it's their heart rates per minute for these 50 students. Now, when you look at all of this data here, it's very difficult to comprehend what is actually going on. So what you actually do with a frequency distribution is you group your data. So it's grouped data, always with a frequency distribution. Okay, they're into categories or into ranges. You're going to group them. So I have here, I've got 5 different ranges. Okay, and what I'm going to do for each one of these ranges, I'm going to go through my data and see how many people fall into that particular range. So if you look through all of this data of 50 students here, you'll see 2 of them have a heart rate of between 57 and 66. 10 of them have a heart rate of between 67 and 76. And you can keep going, okay? And all you've done is counted them. Whenever you do this, okay, and if they gave you a big set of data like this of 50 students, and then they ask you how many fall into each category, a great way to double check at the end that you haven't missed anyone is that all of your frequencies here should add up to the total number that you started with. So your total number of students here should add up to 50. If they don't, then you've missed someone somewhere. But what I would do is write them out and cross them off as you go through. Okay? There's a few things that they might also ask you about frequency distribution tables. Okay? Number one is they may ask you the midpoint of a class. Okay? A class is just one of these groups, one of these categories, one of these ranges. Okay? So each one of these is a class. And you are looking at how many people fall into a particular class. Well, they may ask you what is the midpoint of that particular class, and they may pick any one of these 5. Okay? In order to find the midpoint of a class, okay, all you have to do, okay, you're basically finding the average of the 2 points, of the 2 endpoints. So to find the average, you would do 57 plus 66 divided by 2. Okay, it's the max value in the class plus the minimum value in the class, and then you divide that by 2. So you add the 2 endpoints, divide it by 2. So in this case, what we would have for the first class, let's say for the first class, they said, what is the midpoint of the first class? I would do 57 plus 66 divided by 2. If you add that up, I think that comes to 123 over 2, which if you work that out, I think comes to 61.5. Okay, this number here lies right in the middle of these 2 numbers. Okay, so whenever you need to find a midpoint of a class, just add the 2 endpoints, divide by 2. The other thing that they may ask you is to find the width of the class. Now, any frequency distribution that you come across should have the same width for every single one of the classes. We'll start with that, okay? Each one of these classes should have the same width, okay? Now, this is where a lot of people make a mistake, so make sure you pay attention to this. A width of a class, you would think, would be the maximum value in the class minus the minimum value in that class. So you would think for the first class it would be 66 minus 57. The problem is we haven't accounted for any decimal heart rates here. So what you need to basically remember is that anything from 56.5 and above would round to 57, okay? And anything below 66.5, okay, actually not including 66.5, but they actually go up to that value, but they say anything below 66.5 would round down to 66. So let's say someone had a heart rate of 66.3. Well, that would actually land in this class because it rounds to 66. So whenever you get one of these questions, when they ask you what is the width of any particular class, okay, again, remember that every class should have the same width. Okay, we're going to make a note of that. Every class has the same width. Okay. But when you find the width of a class, make sure you remember to include the decimal values that round to the endpoints. Okay, so this class here could actually be anywhere between 56.5 through to technically 66.49 reoccurring. Okay. Okay, so what we tend to say is instead, let's go from 56.5 to 66.5, okay, because this number here would round to that. then my next class would be anything between 66.5 to 76.5. Okay, because any value inside that range rounds to something in that particular class. Okay, so whenever you find a class width, make sure you account for the decimals first, then you can do the maximum minus the minimum. Okay, so in this case, our class width is the max value in the class minus the minimum value in the class, and make sure you account for decimals. Okay, so in our example here, okay, the width of any one of these classes, so let's do it for the first class, would be 66.5 minus 56.5. Which is 10. Okay, so the class width in this case is 10. You should find that that is the same for every single one of these classes. So for our second class here, it would be 76.5 minus 66.5. Okay, and again, that would be 10. So whenever you get one of these questions, it's normally one of these three questions. It will be either find the width of the class, find the midpoint of the class, or they may give you a set of data like this and they may ask you to fill in the frequencies of each of the classes. So they will say to you, how many times did this particular class happen? So how many times did we get a heart rate of between 57 and 66? How many times did we get a heart rate of between 87 and 96? And you just have to go through your data here and count up how many times you see a number that falls within that particular range. Okay, so that's normally the questions that you get. There are 4 more terminologies that you'll need when you deal with frequency distributions. Okay, first one we've already discussed is frequency. And as we've said, the frequency of something is how many times something happens. So in this case, it was how many times did we get a heart rate of, like, between two values, okay? How many times did we get a heart rate of between 57 and 66? How many times did we get a heart rate of between 67 and 76? Okay, so the frequency is just how many times something happens. Okay, next we have cumulative frequency. Okay, cumulative frequency, all this does, and we use this down the line as well, cumulative frequency is when you add together everything in that class with everything that came before it in previous classes. So if someone says to you in this example, what is the cumulative frequency of the class 77 to 86? Okay, I would take the frequency of that class and add it to every other frequency of the classes that come before it. So I would do, for the cumulative frequency of 77 to 86, I would do 32 plus 10 plus 2. Okay, so cumulative frequency is adding together the frequency of a particular class with the frequency of every class that comes before it. So if they said to you, what is the cumulative frequency of the class 87 to 96? Well, I would take the frequency of that class, which is 5, and I would add it together with every frequency of the classes that came before it. So I would say that the cumulative frequency of 87 to 96 would be 5 plus 32 plus 10 plus 2, which is 49. So the cumulative frequency of the class 87 to 96 is 49. Obviously, remember that we should find that the frequencies of each of these classes should add to the total number of things that I started with. So I know that these frequencies must add to 50. So the cumulative frequency of your final class, which is the frequency of that class added with every single frequency of the classes that come before it, okay, should add to the total number of things that you started with. So the cumulative frequency of the last class equals the total number of people in the study, okay, or the total number of things in the study, okay. In this case it was 50 students, so I know that the cumulative frequency of my final class should equal the total number of people that I took the heart rates of in this case, which is 50. Another type of frequency that we have is the relative frequency. And all the relative frequency is the proportion of people that fall into that particular class, okay? So in this case, what you would do is you just take the frequency of each one of the classes and divide it by the total number of people that were surveyed or observed, okay? So in this case, the relative frequency, let's say, of my third class here, my relative frequency of the class 77 to 86, well, I had 32 people that fell into that class out of the 50 people that I started with. So my relative frequency is 32 out of 50, okay? Now you can write this as a fraction. It's normally seen as either a fraction or a decimal. Occasionally you'll see it as a percentage. Okay, it's easy to do in this case. So we've got 32 out of 50. If you wrote that as a decimal, it would be 0.64. Okay, if you wanted it as a percentage, it would be 64%. Okay, but they will tell you in the question how they want you to write it, but normally it's as a fraction or a decimal. Okay, so the relative frequency is just the proportion of people or things that fall into that particular class. So all you do is you take the frequency of the class that they are looking for and you divide it by the total number of people in the survey or in the study. Okay. So as I said, for the class that we were looking at back here, okay, my relative frequency of the class 77 to 86 was 32 over 50, or 0.64. And finally, we have cumulative relative frequency. So I'm combining two ideas here. Okay. And literally you do exactly like it says, okay? I'm going to be combining both cumulative and relative frequency for a particular class. So remember, cumulative frequency of a particular class was where I added together the frequency of that class with every class that went before it. So that's the first thing that you're going to do, okay? So let's come back to here. The cumulative frequency will stick with this third class. The cumulative frequency of that class would be 44, okay? Because I add 32 plus 10 plus 2. So the cumulative frequency of this class is 44. To find my cumulative relative frequency, I then need to see the proportion of the cumulative people that fall into that class out of the total number of people. So I take my cumulative frequency and I divide it by the total number of people in the study. Okay? So cumulative relative frequency is where I take the cumulative frequency of that particular class and then I find the relative frequency of that cumulative frequency. Okay? If you do this and you go through this, you should find for this last class, it should equal 1 or 100%. Why is that? Well, if we take the cumulative frequency, we know the cumulative frequency of the last class should add up to the total number of people that I surveyed or that I observed. So if I took the cumulative frequency of my last class, I know it's 1 plus 5 plus 32 plus 10 plus 2 would be 50. And then if I find that relative frequency of that cumulative frequency, I get 50 divided by 50, which is just 1. Okay, or 100% if you did it as a percentage. Okay, so your cumulative relative frequency of the final class should always be 1. Okay, you've dealt with 100% of your data by doing this. So, cumulative relative frequency is where we take the cumulative frequency of a particular class and then you find the relative frequency of that cumulative frequency. And as I said, the cumulative relative frequency of the last class should be 1. Okay. That's everything you need to know for 3.1 through 3.3. So you should be able to do those 3 homeworks now, 3.1, 3.2 and 3.3. If you have any questions on this stuff, this is Tuesday's video, so please come to class on Wednesday if you have any issues with this material. In Wednesday's video, so tomorrow's video, I will be going through 3.4 and 3.5, and I'll also be introducing application 2, where we're going to be dealing with some graphs on Excel. So make sure that you have your laptops available with Excel downloaded on them for the next class. Okay. I will see you in the next video and let me know if you have any questions.